We use electricity for many purposes to make our tasks easier. For example, we use electricity to operate pumps that lift water from wells or from ground level to the rooftop tank. What are the purposes for which we use electricity? Electricity makes it possible to light our homes, roads, offices, markets, and factories, even after sunset. This helps us to continue working at night. A power station provides us with electricity. However, the supply of electricity may fail or it may not be available at some places. In such situations, a torch is sometimes used for providing light. A torch has a bulb that lights up when it is switched on. Where does the torch get electricity from? We would discuss this and so many interesting facts in this chapter, Electricity and Circuits. Hello and welcome to the channel. We are going to have a joyride. So hit on the subscribe button before we start the chapter. Our first topic is electric cell. Electricity to the bulb in a torch is provided by the electric cell. Electric cells are also used in alarm clocks, wristwatches, transistor radios, cameras, and many other devices. Have you ever carefully looked at an electric cell? You might have noticed that it has a small metal cap on one side and a metal disc on the other side. Did you notice a positive sign and a negative sign marked on the other side? The metal cap is the positive terminal of the electric cell. The metal disc is the negative terminal. All electric cells have two terminals, a positive and a negative terminal. An electric cell produces electricity from the chemicals stored inside it. When the chemicals in the electric cell are used up, the electric cell stops producing electricity. The electric cell then has to be replaced with a new one. A torch bulb has an outer case of glass that is fixed on a metallic base. Do you know what is inside the glass case of the bulb? A thin wire is fixed in the middle of the glass bulb. The thin wire that gives off light is called the filament of the bulb. The filament is fixed to two thicker wires, which also provide support to it, as shown here. One of these thick wires is connected to the metal case at the base of the bulb, as shown here. The other thick wire is connected to the metal tip at the center of the base. The base of the bulb and the metal tip of the base are the two terminals of the bulb. These two terminals are fixed in such a way that they do not touch each other. The electric bulbs used at home also have a similar design. Thus, both the electric cell and the bulb have two terminals each. Why do they have these two terminals? Do you know? If yes, comment below. Now let's go to our next topic, an electric circuit. The electric circuit provides a complete path for electricity to pass between the two terminals of electric cell. The bulb glows only when current flows through the circuit. In an electric circuit, the direction of current is taken to be from the positive terminal to the negative terminal of the electric cell as shown here. When the terminals of the bulb are connected with that of the electric cell by wires, the current passes through the filament of the bulb. This makes the bulb glow. Please note that one terminal of the bulb is connected to the positive end of the battery and the other one to the negative end. Now, if I ask you if the bulb would glow in the circuit shown here or not, what would your answer be? See it carefully. You would notice that the two terminals of the cell are connected to the single terminal of the bulb. This is as good as the bulb not being connected in the circuit at all. We know that the two terminals of the battery should be connected to two terminals of the cell. So, in this case, the bulb will not glow. Sometimes an electric bulb does not glow even if it is connected to the cell. This may happen if the bulb has fused. Look at a fused bulb carefully. Is the filament inside it intact? An electric bulb may fuse due to many reasons. One reason for a bulb to fuse is a break in its filament. A break in the filament of an electric bulb means a break in the path of the current between the terminals of the electric cell, right? Therefore, a fused bulb does not light up as no current passes through its filament. Now tell me, why the bulb would not glow in the arrangement shown here? Any guesses? Look carefully. Well, the bulb will not glow in the given arrangement because the holder of the tester or screwdriver used in the connection is made of plastic, which is an insulator, and the insulators do not allow the electric current to pass through them. Thus, the current will not flow in the circuit. Now let's do an activity. Complete the drawing shown here to indicate where the free ends of the two wires should be joined to make the bulb glow. Do you want to try? Let me give you a hint. The bulb would glow when the current flows through the bulb, and it would happen when the circuit is closed, right? So, to close the circuit, one end of the wire should be connected to the battery and the other end to the bulb. The bulb now glows. Nice. Now let's talk about switch. I'm sure you must have used a switch. What is it? Well, a switch is a simple device that either breaks the circuit or completes it. Thus, an electric switch's purpose is to open or close an electric circuit to use an electrical appliance. When a switch is on, it completes the circuit and thus it allows current to flow through. When it is off, it breaks the circuit and prevents current from passing through. Many electric switches operate by creating an air gap between two contacts to break the circuit. Some electrical devices with built-in switches include electric lamps, coolers, washing machines, table fans, TVs, etc. I'm sure you all must have seen these electrical appliances. Yeah? Now, the switches used in lighting of electric bulbs and other devices in homes work on the same principle, although their designs are more complex. Now, let me show you the inside view of a torch. The slide switch that you see here can complete the circuit, thus making the bulb glow or break the circuit. Next is electric conductors and insulators. Materials which allow electric current to pass through them are conductors of electricity. For example, metals are good conductors and hence electric current can flow through them. Insulators do not allow electric current to pass through them. For example, thermocol is an insulator. And do you remember there was a screwdriver in the circuit which was an insulator and hence it did not allow the electricity to pass through the circuit. Now, if I ask you, is air a conductor or insulator? I don't think you would be surprised when I tell you that air is an insulator. This is because air is a gaseous substance and gaseous substances are poor conductors of heat. Do you know why? This is because their molecules are loosely spaced. So they can't form an entire circuit. Now answer this. Instead of metal wires, can a jute string be used to make a circuit? Comment below and tell. Now, I have another interesting question. Using the conduction tester on an object, it was found that the bulb begins to glow. So, is that object a conductor or an insulator? I'll give you a few seconds to think. Done? Shall we discuss the answer now? Okay, here we go. When the two free ends of a conductor tester are touched with an object, then the bulb of the tester would glow if the object conducts electricity, right? However, the bulb would not glow if the object does not conduct electricity. So, in our case, the bulb glows when the tester is touched with the object. The object must conduct electricity, right? Hence, the object is a conductor. Please note that conductors and insulators are equally important for us. Switches, electrical plugs, and sockets, they are made of conductors. On the other hand, rubber and plastics are used for covering electrical wires, plug tops, switches, and other parts of electrical appliances which people might touch. Here I would like to give you some caution. Your body is a conductor of electricity. Therefore, be careful when you handle an electrical appliance. Now, if I ask you, why should an electrician use rubber gloves while repairing an electric switch at home? Electricians use rubber gloves when repairing an electric switch. Why? To protect themselves from electric shock and burns, because rubber is a bad conductor of electricity. That is, it is an insulator. Now, since you know this, tell me something. The handles of the tools like screwdrivers and pliers used by electricians for repair work usually have a plastic or rubber covers on them. Right? Have you ever noticed? Now, do you know why? Again, the handles used by electricians for repair have covering of plastic or rubber, which is an insulator and hence does not allow electric current to pass through it. Thus, electric current does not pass through these tools to the body of the electrician to harm him. Make sense? And guess what? We just completed the chapter in just 13 minutes. Can you believe it? It was fun, wasn't it? So, quickly like, subscribe, and also share with your friends and tell them this easy and fun way of studying. Comment below how many stars would you give this video out of 5? And do you want me to make more such videos for you? I gotta go, but till we meet next, stay kind, make healthier choices, and keep learning. Check our other videos too. Studying can be fun and informative. So, keep learning. Lots of love. God bless.